Do we have sound? Yay, we have sound. Do we have images? Yes, awesome. This is awesome. Welcome. We're going to talk about the GitHub extension for Visual Studio, which is a .NET extension app running on Visual Studio built by GitHub that is open source. So my name is Andreia, like Ian so kindly presented. I work at GitHub. Before that, I was at Unity and Xamarin and Novell working on the Mono project. So I'm actually really happy today that the Mono runtime is finally MIT and released. So yay, extra happy for the day. And today we're going to talk about how the project got started, how we planned it and released it, and the problems that we have, the challenges that we had to face, the whoopses that we met along the way, and how we open sourced. Hopefully, you'll come out of this with, if you're building extensions or if you're planning on building extensions, all of this stuff is open source. The code is there. There was a lot of banging heads against the wall to try to figure out this stuff. So hopefully, you don't have to. you can still code and make your life easier. So let's start by the planning phase. What is the GitHub extension for Visual Studio? So it's basically a Visual Studio extension, which is basically a class library. It's just a DLL, a bunch of them, packed in a little zip file that Visual Studio, the installer just unzips somewhere and then Visual Studio loads. The particular challenges with the extension is that it is integrated with Team Explorer. I'll show what it is in a bit. So basically what it does, the main features of the GitHub extension is that it handles GitHub authentication and credentials for you. So when you're in Visual Studio, you can do Git operations without having to fight the system or come up with personal tokens or just have random Git operations fail because the credentials are not there and Visual Studio doesn't know how to deal with GitHub credentials. This is the main thing, actually, that it's the main hidden feature of the extension. Just make sure that people can log in and do Git on Visual Studio without having problems. Then we can also, the first features that we have when we launched were be able to clone and create repositories, because why not? And then Visual Studio takes care of the Git operations for us, and we already have the credentials there, so it's kind of like getting your code into Visual Studio and being able to work a commit and do all of these things. We're now adding new features to the extension and extending it with more GitHub integration. So we already have ability to link and open code from Visual Studio into GitHub. So you can share, if you're looking at some piece of code and you want to share that with your colleague or you need to talk about something, you can just quickly create a link that highlights that piece of code that you're looking at or just opening it in GitHub for quicker collaboration. And this feature came to us, the suggestion from an external contributor because they wanted to quickly share code with other people. They're trying to, I'm looking at this, I have no idea what you're talking about, I'm not in your screen, so quickly sharing the code is good. Gist support is something that is coming very soon, so you can create, just highlight code and create gists very quickly from Visual Studio. Also coming from external contributor, and pull request management. So you can see your pull requests, create new ones, and handle all of these. This one is a feature that we're working on. It's a big feature, so it's going to take a bit more time than I wanted to ship it out, but hopefully it's going to come out. Team Explorer is the team collaboration source control area in Visual Studio that came out in Visual Studio 2013. It's on the sidebar next to Solution Explorer and all the other little panes. It gives you a view of your local repositories, so you can easily switch between them. Anything that you've opened that is a Git repo in Visual Studio is basically listed there. And it gives you access to all the operations, Git operations, so looking at branches, history, and syncing, publishing, and doing all of this stuff. It's shipped as an extension itself, so it's not something that's, it's the first kind of project that Microsoft has done where they don't ship it in the box with like built-in and tied closely with Visual Studio. It's just another extension that happens to be shipped with Visual Studio itself and provides us with some critical information that we need for actually having GitHub integration, which is basically services that gives us like what repo are you currently looking at, where like your solution that you have opened, where is it, and also services for cloning. So Visual Studio clones for us, and we don't have to re-implement all of the operation, the underlying plumbing for doing that. So when we started this, the first commit was December 12th, 2014, by Phil, who was very excited getting this party started. I was hired and started working at GitHub on January 6th to work on this. And my first commit is January 14. And from that to launch was 3.5 months, because launch was April 30, and we had to launch no matter what. That was the launch date for Visual Studio 2015. That was the launch date. That was the date of build. So we had exactly 3.5 months to build everything from scratch and get it out there. And this required using APIs that were not available because Microsoft hadn't shipped Visual Studio. So nothing was available. There was a bunch of previews of Visual Studio, but not the stuff that we wanted and needed to use. So we basically spent 3.5 months in calls twice a week with Microsoft, coordinating what APIs we needed, what we needed to do to be integrated with them, because we are inside their UI. We're not separate, so we need to match styles, we need to match behavior, we need to conform to a bunch of strict requirements that they have for those areas that, as an extension, you wouldn't have. So we spent 3.5 months trying to figure all of this stuff out with kind of following the Microsoft sprint cycle, which is 2-3 weeks of sprints, where this is what we were going to do in this next sprint, and then it might not be done, it might not be finished, but it's a goal, and then we test and ship and demo, and then next. And for the roadmap, basically, that we had for doing all of this was we had no room for mistakes. 3.5 months is not nearly enough to ship a product that is polished and nice and usable, allowing for any mistakes. If anything went wrong, badly wrong, that took like 2 weeks to fix. That was 2 weeks that we couldn't do anything else. So we had to follow a very tight roadmap. So we did that by identifying the areas where, because it was only me and Phil, basically, doing this for 3.5 months. And Microsoft helping out with APIs and telling us what we couldn't do most of the time. We had to map out what we needed to make sure that we could, what time we had to spend up front so that we could save afterwards. That meant building a CI, build bots, setting up scripts to build the extension that matched the same things that I would have built when I build in Visual Studio, because I'm developing in Visual Studio, I'm building and testing and debugging. But the build bots are not building in Visual Studio, they're building with MS Build on command line. And there are differences between building on the command line and building on Visual Studio. So up front, we had to make sure we knew that we had to have solid build infrastructure that would guarantee that I didn't have to do builds for release on my machine, that the build bots could always build for anyone, and it was always reliable. They would always build, they would always run tests. This means that every commit for the repository would get built, and unit tests would run immediately for every single commit that we did, so that we know for sure if we broke something, or at least that if someone needs a build, we don't trust individual machines to do this. We have a structure. And then spending a while figuring out how to architecture and design the project itself in terms of splitting interfaces from implementations on separate assemblies, understanding the lifetime of the things that we needed to create. Visual Studio is heavily based on MEF, which is no lifetime control, basically. It just creates stuff for you when you need it and then destroys stuff when you don't need it. Yeah, who is here familiar with MEF? So it's a framework that creates instances of things for you instead of you going new something. And this is the simplest explanation because there's more. It's a managed entity framework. You specify in a constructor for your class which types you need, as you would when you go new and then you pass parameters. And instead of going new and passing the parameters, you request the system to give an instance for you, and it will create it. You create the entire tree of all the objects that you need and give you an instance of it. So it's just managing objects in lifetime and scanning all the assemblies that export things that might need to be created, so anyone can just request, give me a service of this type. If that service doesn't exist, it will create it and give it to you. And there's lifetimes for this. You can specify that something once created is always shared. Everybody gets the same instance, and then you have a singleton in your system. Or everything is unique, and every time someone requests an instance of something, they will get a unique new instance with everything that instance depends on also created. It's very hard to manage lifetime of objects when you don't control the creation of objects, and it's very easy to leak. It's very easy to leak memory, and it's very easy to just suddenly have so many dependencies that you just instantiate a million objects because this just goes down the tree. So making sure that we understood how Visual Studio works in this architecture, because Visual Studio does all of this, and just making sure that our extension we could control and knew what was going on was a thing that we invested some time up front to figuring out how to do this. And then just splitting tasks for the team. I was very new to the project. I literally started on the day that I started coding. So there was a lot of code that we took from GitHub for Windows, which is also a .NET app. A lot of the UI there, a lot of the code for OctoKit and all of GitHub API and libgit integration, we took it from GitHub for Windows. And Phil was very knowledgeable about GitHub for Windows, so he took that part. He knows those bits, and I took on the part of banging my head against the wall and making Visual Studio work. So it was a nice split. So the challenges of creating this specific extension are all the challenges of creating normal extensions for Visual Studio. As in, if your extension crashes, you take Visual Studio down with you, which is not a good thing, especially when you're collaborating with Microsoft, and they might get annoyed at that. But also the fact that we have two different UIs that are running. The Team Explorer UI is, let me see if I can stop this for a second. Yes. I'm going to show you this so you can actually see what's going on. So this is Team Explorer in Visual Studio. You can see like the title, home, up here. This is all Microsoft. Microsoft renders and controls all of this stuff. It's part of the Team Explorer extension. This is ours, but not, the title is ours, not the tooltip. This we render. It's our little icon. This is not ours, this is not ours, this is ours, this is not ours, this is ours, ours, not ours. So in this UI, we are embedded in someone else's UI. We don't control how it gets rendered, when it gets rendered, how it gets created. The only thing we know is we have to implement a class that specifies what the icon is loaded, doing some of this is XAML, some of this is not. Some of this is just me putting these little buttons, is me saying, here's an icon, here's a title, and it renders. And here's the behavior when you click it. This here is XAML, but the title isn't. So all of this stuff we needed to do the UI specifically for this. And then also, of course, because it's Visual Studio, we have to obey theming. So anytime you change the theme, we actually have to make sure that the icons get rendered correctly, that the text flips, and all of this stuff. On the other hand, yes. Okay. So we need to do, so on the Theme Explorer side, we need to do very specific UI. There's a bunch of classes, very specific classes that we have to implement. We have to obey themes, and it's all callbacks. There's like the constructors can't do anything. Like Visual Studio calls some methods when it's initializing the UI, so we can do things, and we have no control over when this stuff gets created and destroyed at all. It's Theme Explorer and Visual Studio doing it, so we have to make sure that we are performant, that we obey styles, and that we all do all of this stuff. But then there's the other UI, the UI that happens when for instance, you want to clone a repo when you log in or create. And this UI follows our design, follows the GitHub design for apps, follows the desktop style very closely. It's not themed, as you can see, and this was actually something that Microsoft wanted us to do, so that this was our own branding, and it's our UI versus Theme Explorer UI. It's not confused. So this UI is completely different. It's actually, most of it is taken from GitHub for Windows, and it doesn't obey theming, and there's a lot of completely different icons and everything else. So and also hosted in the dialog as opposed to inside Visual Studio, which implies that it's modal. You can't use Visual Studio while you're looking at that window. So there were challenges here that we had to work with. Another problem was that we have a lot of reactive code. We have RX.NET and reactive UI in a lot of our things. And Microsoft upfront said, we don't want any of these dependencies when you load. Because Theme Explorer Home is the first thing that you load in Visual Studio. It loads very, very early, and it's very heavily monitored for footprint and performance. So any dependencies that we bring in just because we have some reactive code that we want to reuse, nothing. So we couldn't actually reuse any of our UI to load any of this stuff. And that created a problem in that we actually had to split the architecture of the extension on reactive versus non-reactive, to make sure that, one, I don't make a mistake and accidentally start getting dependencies that I don't want, and that you really can't fall into the trap of, oh, I'm just going to call this method, and here come 30 dependencies, and then Microsoft's screaming at me. So this is actually, if you go to the project and you see there's like a million DLLs, a million little class library projects, some very small, some big. And most of it is because of this. If you have data that is going to be shown in Theme Explorer Home, and then Home is the most critical one, no reactive, as fast and minimal as possible. There's code dedicated for this, and some GitHub APIs, a little DLL that just handles this stuff, data for this stuff. And then everything else that can use reactive is split off on the other side. And so this guarantees that if anyone is distracted, they won't actually screw up anything. Other problems were testing. Kind of a big problem in that you can't really test Visual Studio without testing all of Visual Studio. You're trying to test your UI. If you want to automate your UI and you're in a standalone app, you can use automation APIs or do something else, or fake mouse clicks or whatever. It's your app. You can build things to do this. Visual Studio, not so much. We're running inside Visual Studio. We would basically be testing the whole of Visual Studio. So we kind of have a lot of unit testing. We use interfaces a lot to make sure that we can easily unit test individual bits. We hide away anything that is Visual Studio specific, like services that we are using, because we would have to kind of mock or re-implement the entire infrastructure just to recreate the behavior so we could test our bits. So we create little layers of abstraction to hide away all of those things so we can just fake the behavior when we're testing our side and hope that Visual Studio doesn't break the behavior, hopefully. So unit testing is a big thing that we do. Integration testing, not so much. We have a lot of manual testing, and our QA people have a manifest of everything that they need to go and click. One day I want to have an automated framework that I can use to test this stuff, but for now, not so much. Then we have installation. So the V6 is an installer. It's a zip file that gets installed by an installer. It's a fairly simple process. It's really small and easy to ship, but Microsoft didn't want to ship a V6 because their installer didn't support V6. They wanted an MSI. MSI, not so much. MSI is hard to make and hard to automate. And again, I didn't want to have to go and manually fix files every time I wanted to ship releases. So I wanted a system that could make installers for me where I could automate bumping versions and doing all of this stuff. So Wix, the Wix tool set is a really nice thing because it has an XML format. You can just go in there and just read it and bump the version. And you can run other installers. So I can just have a MSI just runs the V6 installer. Unfortunately, MSI only looks for the 3 parts of a version, and V6 looks for 4. So suddenly all our versioning schemes didn't get obeyed by the MSI. And then you want to do semver, but it doesn't quite work because you don't have the 4th part. So fortunately, Microsoft added V6 support for their dynamic installer, so we no longer have to ship an MSI. So that makes me happy. So those were the challenges that we knew were we predicted up front. The stuff that I saw coming a mile away. So just reserve space to do that, and that's it. The other problems that we didn't quite see up front were dependency problems for assemblies that we linked to. We use NuGet to get packages. Why would I build my own stuff, right? There's NuGet. I need OctoKit, I need libgit2, I need Splat, I need React. Just get NuGet packages, and that's it. I'm very conservative about my updates of versions of packages, but I'm not updating them every day, so it's fine. The problem is we're not in a standalone app. We are in Visual Studio. There can be a million extensions running. They can all be loading exactly the same assemblies that you are, but completely different versions. And the problem with .NET is that versioning is ignored by the runtime if the assembly is not signed. That's pretty much it. Signing an assembly is versioning the assembly. And if you're depending on something that's not signed, it will ignore the version that you're requesting. If there's another version that's already loaded, it's like, close enough. You can take this one. It works, right? Of course, it doesn't. This one I kind of saw halfway, and I'm going like, yeah. Anyone can break us by just loading whatever they want. And if they load before us, I have no idea what they're loading. I'm going to get whatever comes up, and then it's going to blow up. Also, Team Explorer ships with libgit2sharp, and we needed our own libgit2sharp. So I had to fork and sign everything, basically, because I couldn't get the upstream projects to actually sign them. There's a lot of discussion on the open source.NET community about signing versus non-signing. And that discussion, it's like I just didn't have enough time. So I basically have 5 or 6 submodules that are the upstream versions plus signing, and I just link against all of those. And then I am sure that whatever gets loaded is my version. Icons, apparently it should be easy loading these little icons, and we're in DPI land. This stuff should be fixed, right? Not so much. Visual Studio until now still use bitmap lists. If you want multiple sizes of icons, you make them and you put them in. I have no idea how to use this stuff at all. I gave up. I was like, I don't know, Microsoft, help. So they were very nice and actually gave me their solution, which is now documented and up somewhere, buried in MSDN, which is a magic manifest file where you can just link to your XAML icons. And they will just load them and render them at whatever DPI you happen to have, and it will always look pretty. And then you put a magic file in the VSCT file that defines your menus or icons and say, icon is moniker, and magically it works. Total magic. Like, I don't want to see this ever again, it works. Done. Resource caching, big problem. So this is not a standalone app, again. Standalone apps have a little app.xaml file where you can put all your global resources that you always know you want to load. It will only get loaded once, and it will be shared across your app. This does not exist for DLL projects, library projects. V6 is a library project, so there's no centralized place that can easily share resources across your app. So I made one. I just created a shared dictionary.xaml, put everything in there, and then everybody else links to this shared dictionary.xaml. Every single project that defines XAML resources just has this, and then just everybody includes everybody else. But it doesn't really solve the problem, because it will get loaded with every single XAML file that you load. And since Team Explorer, every time it gets loaded, our UI gets loaded there, it will like create a new. It's a new instance. There's no sharing there. Every time you load any UI, all of the resources get loaded again and again and again and again. Not really good performance. And there's no way of doing this at all for library projects. So you hijack the source property. You cheat. I'm going to put this in. There you go. So you cheat, and you do this. You do this is a resource dictionary, just a subclass of a resource dictionary, right there. And just overrides the source property. And then the first time it gets called, it caches whatever, it loads the caches, calls base, because base is smart and knows what to do with XAML, right? When just every other time that it goes through here, it's just, oh, I've already loaded this here. This is actually how Team Explorer does it as well, so I can't take credit for this. I just like, it's the most hacky thing ever, but it works. Well, kind of works. So that works, right? Then suddenly things only loaded once, and they're shared and cached, which is important, especially when we have performance and footprint considerations in critical areas in Visual Studio. Only no. So the XAML designer in Visual Studio completely ignores the source property and does not run the code at all. So as soon as you have a overridden source implementation, it just completely ignores the whole code and nothing gets loaded. So it's fine at runtime, but at design time, you can't see anything. There's nothing. No resources get loaded. And if neither in Blend or Visual Studio or anything. So every time you're designing in the blind, you're trying to figure out how things would look, and then running and looking and then stopping and tweaking and what. So what we did was basically just have a separate build configuration in the solution that if defs out the little source property override, so you can actually see it at design time. It's, again, hacky, but it works. At least my designer now can actually see things and tweak the styles without having to run Visual Studio all the time. But XAML designer, no. Also, we had a little other problem where Team Explorer is loading so early that Visual Studio didn't actually have time to set assembly paths loading properly. So it wasn't finding our DLLs. It found the XAML, and then when it tries to load the DLL that corresponds to the the dependencies. It just broke completely because it's running so early that Visual Studio hasn't initialized yet. So that we also fixed in the shared dictionary manager by overriding the assembly runtime load and putting the proper paths in place because we know them. But this is, like, again, another problem that we are stuck in someone else's UI with someone else's lifetime management resources, and we don't control anything, so we have to fight the system. So after fighting the system, we launched. Yay, April 30. It was awesome. A lot of great conversations. Build was amazing, and we had people coming in and being able to log into GitHub and Visual Studio and do all their work instead of using something else. We had a few crash reports on that day. And there were two main issues on that day that were very interesting, and in hindsight, probably avoidable. Rx.net. So remember how I said that I was forking and signing every single dependency to make sure that what got loaded was the thing that I wanted? I didn't do that with Rx.net because Rx.net is signed. Like the package is signed and versioned. There's no reason to do it, right? Turns out Rx.net ships two assemblies, two versions of the same assembly. One built with .NET 4 and one built with .NET 4.5. It's the same version, same signing key, Rx2, whatever, but two little profile builds. And they're not the same. The 4.5 version has extra methods that are not in the 4.0 version. And Xamarin happens to build against the 4.0 version because they've been shipping since 2013, 2012. So they naturally had an earlier .NET version for compatibility as well. And we're 4.5, because why not? And they load first. So when they load their version of Rx.net, which is the 4.0 profile build because they're a 4.0 .NET app, and then we load, and then at some point, a method gets called inside Reactive UI, which calls some method in Rx.net that doesn't actually exist because it's the 4.0 version. So that was fun. I had to fork Rx.net and sign it with a different key. Actually build a NuGet package so I didn't have to, like, you as a contributor wouldn't have to actually build Rx.net as part of the project. Let's just build a separate package that just got the thing and re-sign it with a different key so that I know that when I load the version that I want. Xamarin later changed the version, so they're now shipping with 4.5, but I can't trust that anyone else is going to load before me and break me. It's impossible. There's no load order. So Resharper was another interesting one. I got Matt from Resharper from JetBrains coming to me at the booth at Build saying, like, we're trying to log into the GitHub extension. It's really slow. And like typing, every character took 1 second to show up on screen. It's like, this is weird. And at some point, we figured that it was only when Resharper was loaded. And they suggested it might be threading issues because they know that Resharper injects itself into every single window in Visual Studio. So if anything gets delayed or slowed down, chances are it's some kind of threading thing going on with us and Resharper. But why would there be threading issues? So this is, we have a bunch of we use Reactive UI, which uses some nice helper libraries to figure out whether it's in unit test mode or not, to fix threading when you're in unit test mode, because in unit test mode, you don't actually want multi-threading and things going all over the place, and most times. You just want to have every test run on their own thread. And the way they detect if they're in unit test mode is by scanning the entire app domain process for all the loaded assemblies for these names. Guess what happens when you do this inside a Visual Studio session? Visual Studio has everything loaded all the time. If you're trusting that a certain thing with a certain name is loaded in the process and then go like, oh, okay, so I'm in unit test mode. Yeah, you're unit test mode in Visual Studio while you're running the extension, right? So basically, they overload the threading module if you're in unit test mode. And we were always in unit test mode, because I didn't notice that this dependency of my dependency was doing this. So that was the lesson of make sure you know what your dependencies are doing. I don't think I could, unless I audited the entire code, I'm not sure what I could have done to figure this one out earlier. With 3.5 months, it's really hard. Basically, I had to take out the code that goes in, I know this assembly name, I must be in unit test mode, or I know this assembly name and I'm design mode. I had to take all of that code out and manually, actually, the unit tests tell the system if they're in unit test mode, because otherwise, you can't make assumptions. Assumptions are the mother of all things. And then finally, we were happy, we're shipping, and now finally starting to polish some things and maintenance mode. And this one happens. So this one happened actually at midnight, my time, which was 3 p.m. San Francisco time. So I'm actually asleep throughout all of this. I wake up and look at my phone and see things. So basically, someone in South Africa, a developer in South Africa, had a repo with an AWS key. He committed that to the repo and then pushed through the Visual Studio extension and checked the little checkbox that says, make this a private repository. Unfortunately, a month earlier, I had done a little tweak of the style of the checkbox because Microsoft was complaining that we were not matching our style with theirs. And we can't use their styles because they're private, so I had to kind of fake it, recreate it, and the way I did it was putting a checkbox inside a checkbox. So the inner one renders and the other one actually is the checkbox. Fortunately, it would all work fine if I was actually binding the property in XAML directly or handling the checked event directly via just a regular command. As if you double click and you just go onto the code behind and handle it, it would be fine. But we're using reactive UI, and reactive UI only checks for dependency property changes. And unlike normal bindings or me double-clicking and handling in a separate event, a separate callback, which is a rooted event that bubbles up, so the inner one would grab the event and just send it up to the outer checkbox. Reactive UI only listens for the outer checkbox checks change, never listens for the inner checkbox check change. So when you check the checkbox, it looks checked, but the event actually never triggers. It never got checked. No private repo. So he published it as a public repo, didn't notice. And then a bot that scans GitHub for AWS keys grabbed this key and started throwing instances of Amazon and doing Bitcoin mining, I think. I think that was what he was doing. So he accumulated $6,500 in a few hours. So yeah, again, knowing what your dependencies are doing is a kind of a good thing. Also, big failure on our manual testing that we didn't actually have a step for make sure the private checkbox obeys it. So lots of failures on the system that we fixed. Please don't put AWS keys on a repo. Don't put private data on a repo. Stuff can happen. And the timeline is interesting because I was asleep throughout the whole thing. Everybody else managed to do the release before I woke up. And this was a tribute to the fact that we had CI, we had build bots, we had a documented build and deploy procedure, so anyone can go in and there's a bug, we can fix it and we can ship it right now, and then we worry about auditing, making sure the processors are good. So that was like, yeah, yay, a good, bad, good. So open sourcing. We open sourced it July 20. It was always the plan to open source it from the start. We couldn't open source it right from the start because a lot of the stuff that we were using was private with Microsoft. And we had to keep a lot of discussions private and figure out APIs and stuff like this. So after the launch, once everything is out, I went through and cleaned up everything to open source it. And it was actually not very hard because we knew that we wanted to open source, so we made sure that things looked nice and no swear words. There was one, I took it out, and all of this stuff. The best way of doing it is just a clean new repo, just create a new repo. Git filter branch to cull from the history all the files that you really don't want to push, whatever private certificates, passwords, whatever. You can rewrite code, so you can just give it a regex and just take out client ID and secrets from C# files if you have committed them, and then we'll rewrite the entire history and clean up everything, which is what we did. If you really need private bits in your builds, but only for your internal build bots and not for contributors, you just have a submodule that's private. And public contributors can clone and build and everything, and then when you're building internally, you can have these extra bits added in. And comprehensive commit messages save the day, because after 3.5, 4 months of doing this, actually understanding what I was thinking and what I was doing and whether this code needed cleaning, if I have good commit messages, I can figure things out, right? And not only, open sourcing is not just open sourcing. There's a lot of stuff that goes with it. If you open source, but there's no way of people to contribute, there's no way of people to easily build, there's no documentation, it's worthless. So we have a little process, a little checklist for open sourcing things, where we basically make sure that all of these things are done before we open source. And again, commit history is the best documentation out there for anyone trying to understand what's going on. Commit history, right? It's how you communicate what you did. And finally, because we're running out of time, the big challenge with open sourcing this is actually taking contributions and making sure contributors are happy and building the community. This is an app that has UX guidelines, performance requirements. We have our own branding and design style. There's a lot of things that are go beyond just, fix a little thing or implement a feature. And every time I get a contributor going like, here's a little thing that I did for this feature. Okay, now there's 3 weeks of work in taking that and actually making it a feature, a product, right? There's testing, there's polishing, there's UI, there's all of these things. And you can never, ever, ever crash because it takes down Visual Studio and it's really bad. So edge cases and being paranoid about all this stuff is something that, like a contributor might not know up front. So how do you keep a contributor and still have all this process that takes a while? We have a list of contributors over there that contributed the GIST support and the open to link and doing translations, and which are awesome. There's a small list, but I'd love to have it more. It's not easy to contribute, I know, but we try. And thank you.